So today's discussion is about business intelligence systems. And you're probably wondering, what the heck is that? I've never heard of it before. And why should I care, right? So consider this, though. UPS developed this new application called Orion. And the use of Orion basically optimized how drivers delivered their packages. And their goal was to reduce each driver per day their driving distance by an average of 1 mile. So what does that mean? Well, in all, that meant they saved over 85 million miles in a year, resulting in an estimated $30 million per year simply by this one application. That is what business intelligence can do. That is when you have a system that can make intelligent decisions for the business. Okay, so that is the discussion today, is to look at what does it mean to have a business intelligence system. What are they? Why are they so useful? And a little bit more of the details about what they can do, what's needed for them to be successful. So the big questions: how do organizations use business intelligence systems? 2, what are the 3 primary activities in business intelligence processes? How do organizations use data warehouses and data marts to acquire data? And this is part of this business intelligence equation. Number 4, what are the 3 techniques for processing business intelligence data? And number 5, what are the alternatives for publishing business intelligence? And after we get through this, and now this is all part of Chapter 9, after we get through this, we're also going to talk a little bit about geographic information systems, which can often supplement business intelligence systems. So we're just going to dive right into that when we're done with this. But let's start. Business intelligence systems are systems that process operational and other data to analyze past performance and make predictions. Okay, so the idea here is it's not just about recording transactions that go on in the organization. So every time a package is purchased, or every time a packet or product is created, or every time an email is sent, those are all transactions, right? And in and of itself, it's important to know that these things happen and to record that those things happen. But what does that mean? What's the big picture from that? Well, the fact of the matter is a lot of the businesses are capturing this data, this transaction data, and data from other sources and bringing them into the organization. And it's estimated that nearly all sectors in the U.S. economy had at least an average of 200 terabytes of stored data. And this was in the year 2009. So why is that significant? Well, for one, as late as 1999, it was estimated that was Walmart's. So Walmart, one of the biggest retailers, has one of the biggest data warehouses out there. So they store probably some of the most amount of information of every. They only had 200 terabytes in 1999. So 10 years later, it wasn't just one of the biggest companies that had 200 terabytes. Now it's virtually all companies have 200 terabytes of stored data. I mean, think about the explosion in the amount of data that's being stored. So there's tons and tons of data. But how do businesses make the data more valuable? Okay, so we're capturing it, we're recording it, and it is helping us to do our normal stuff, so our day-to-day operations, but we want to analyze this data, to see if there's something that we're missing that can add and help us make better decisions going into the future, and help us to solve problems, and to help us to manage our projects better, and just to inform us about what's going on. Right? So there's different questions that can be asked here. So for example, you want to try to capture data, maybe about, maybe you do an email marketing campaign. Well, how does that email marketing campaign impact your social media system, or your social media interactions, right? Or maybe you're more on the supply side and you ask a question, so how does changing our different suppliers impact the quality of goods and the number of return goods that come from customers. And so there's a lot of things you might be able to start patching together. There's data from multiple different places. And yes, we talked about like ERP systems, which are great at capturing everything internal to the business. And that might be your operational databases or operational database if it's just one. But you also have data coming from a lot of other different areas. So what you want to try to do is now look at this data from multiple different areas and put them together. Analyze it and see if there's something useful that we can pull from that. Now, part of the business intelligence, though, is also getting that information out to the people who can use it, your knowledge workers. And then still, this business intelligence systems have those same 5 components: the hardware, software, data, procedures, and people that we've always had for different types of systems, right? So a business intelligence application is just a software, but we still have people interacting with it. We still have hardware that's being used. You still have procedures for pulling information out or doing something with that information. But the 4 primary business intelligence tasks, and hopefully these 4 look familiar because we've already talked about them before. The 4 primary tasks are project management, problem solving, decision making, and informing. Okay, and so like one of those, decision making, actually there was a series of applications, and I think we might even mention it before, about like decision support systems. And so business intelligence is a slightly bigger concept. It entails much more about what's going on in an organization. I want to rephrase that. A little bit broader scope for these types of applications. However, there are some similarities to it. To even these 4 different tasks, it basically follows and has to include these 3 primary activities. Number 1, you have to acquire data. And I'm not just talking about your transaction data. In other words, every time someone makes a purchase or every time you change your general ledger, right? Yes, you're acquiring data there, but you also can purchase outside data. Or maybe it's not money, maybe it's not something you purchase, but something that's available for free. Right? So if there's data out there that you can use to compare with what you're doing or to integrate with what you're doing, that can certainly add a lot of value. But acquiring data is a huge process. It includes cleansing it, organizing and relating it, cataloging it, so you know what's there. All right, second activity is to actually perform some sort of analysis. So you have all this data, it's sitting there, but that's all it does is sit there until you actually analyze it to try to figure out what's going on. Includes reporting, data mining, big data, and we'll talk about each of those in a bit. And lastly, what you want to do is publish your results. And now some of this might seem rather mundane, such as printing things, web servers, report servers. Well, yes, and some of those may not seem astronomical, but the key here, and I think this is very important, is that when you publish these results, it can be used by knowledge workers to create more feedback. So once things are published, especially if you publish it on a web server, right? So now there's web pages, and now people access these web pages, and every time they access a web page, it creates more new data. So essentially, this process shows a lot of feedback. And this is how the volume of data is growing exponentially. Now, for a while, they were saying it was about every 18 months that data is doubling in size. Every 18 months. So it's very similar to Moore's Law in that instead of now shrinking it's the doubling the number of transistors per microchip. So they're doubling the number of transistors. Now we're saying double the amount of data every 18 months. And some people might have even argued it should be every 12 months. But think about that. So if your organization has 200 terabytes of data today. If they double it when they had 12 months, that means you need 400 terabytes of data next year. And then after that, 800 terabytes. And after that, well, after terabytes, you go to something called petabytes, right? And after petabytes, you go to exabytes. And after exabytes, you get the zettabytes. And after zettabytes, you get the yottabytes. Data is very, very quickly consuming more and more and more space. Now, there's so much of this being created, though, that we are trying to figure out ways to really get the most value from it that we can. Right? And so I do want to emphasize that. So that's what this process is all about, and that's what these activities do. So you acquire data, you perform an analysis, and then you publish the results. Now, at the end there, it says there's two different types of ways you can publish the results using push and pull publishing. And it's really more about how the user is going to perceive it more than the technology behind it. And I won't go into all the details. But essentially, push publishing essentially means that the user really doesn't have to do anything. It'll automatically appear in front of them. So this might be like if you're sitting at your desktop and you have Outlook open, emails will pop right up into your email box. So it's been pushed out to you. Now, pull publishing basically means the users won't have things pop up in front of them. They have to go to it to get the information and pull it back to them. This might be a published web page where they have to click on a link to go to a page to see the content or the report. All right. But it'd be either way. So there, I mean, and here's the key though. So you don't want to have too much push publishing, because people, if they get too many things showing up in front of them, it's called the information overload, and they basically just shut everything out, right? And so doing too much push publishing can actually be counterproductive. What you want to do is have push publishing on just the very key important things that are being done. Pull publishing, though, is where most of the stuff is going to be done. But even then, you have to make sure it's easy to find. Otherwise, if there's too much pull stuff, people won't, if they don't know where to go to pull the right stuff, that doesn't help them either. And particularly when we have so much data creating so many new reports and new pieces of information, getting that information out right to the right people at the right time is an extremely difficult process as well. All right. So that being said, let's focus on the acquiring data first. Now, we're actually going to start talking about something called the data warehouse. So where does this come in from, right? We talk about databases, and most of what we referred to in databases back in the previous chapters was referring to what is called a transactional database, and that's what's capturing, or sometimes people call it an operational database. This is where your ongoing operations of the business is being stored. And that's all fine and dandy, but the operations of the database is constantly being changed depending on what's currently going on in the business. What you also want to do is capture this piece of information, these pieces of information, at set periods of time. So essentially what you want to do is take snapshots of that database and say, all right, this is where we're currently at. Let's take a snapshot, and then we'll do this again in 3 months. Take another snapshot, or maybe it's once a month, depending on how you want to set up your data warehouse, right? So at different points in time, you take a snapshot of what's going on. So it doesn't necessarily need to be updated all the time. So what does this look like? It's good to think of it kind of as a multi-dimensional piece of data. And the phrase hypercubes has been thrown around to describe these. So if you know what a cube is, right, a hypercube would just mean it has many dimensions, maybe more than 3. But the picture over here should give you an idea. So you can divide out the data by territory, by product lines, and then perhaps by year or customer segment or timing of advertising. And so you break out the data by multiple different perspectives, in order to capture it and be able to look at it from all these different perspectives, right? So you can look at the same piece of data from all these different perspectives. So where does it all come from? Well, it comes from all these databases, like your marketing database, sales database, customer database, product database, and you plug all that information and save it into your data warehouse. Now, if you're using an ERP system, a lot of it's already combined. However, the ERP, again, is an operational, ongoing thing. You might not want to be running these reports against this, because if the report takes too long, it might actually slow down the server. And that's bad stuff there. So that's where, even though you have an ERP system, you still might want a data warehouse to store it as a separate thing that you can run reports against, but also take snapshots of the ERP data at the right times in order for you to analyze it better. So what are the functions of the data warehouse? Basically, you use it to obtain or extract data from operational, internal, and external databases. So for example, you might have a Facebook page where you have you're interacting with customers, right? So you have your very own Facebook page for your business. Well, you want to compare people's interactivity with the Facebook page with an email campaign, right? So these are coming from one's internal, but the Facebook data is actually coming from Facebook. It's external. But you want to combine those together in order, like, take a snapshot in time and say, all right, at this time we did this, and this is the result on Facebook. And so now you can do a comparison. And that's awesome, but you also have to realize that sometimes the data, when they're coming together from these disparate sources, might have different ways of defining things, which requires you to redefine them, which is called cleansing of the data. So Facebook might call comments by one term, but somewhere else you might define it as, posts, or vice versa, right? So you have to define the terms the same way. Then you have to organize, relate, and store in a data warehouse. You can still use database management systems to interface between data warehouse applications and BI applications. So those database, database management systems still come in very handy. Excuse me. All right. And the data warehouse has to maintain a metadata catalog, again, describing what data is in it. So if you want to look at it more visually, this might be one way of doing it. So the data warehouse, you have a metadata, and you actually have the database itself, and you use a database management system for the data warehouse. You pull in data from multiple different places, you clean it, you prepare it, and then it gets inputted into the data warehouse. Once the data is in the data warehouse, then you can extract it using business intelligence tools. So the users of the business can hopefully make good decisions based upon, or solve problems, or whatever they need for the organization to be more intelligent about what they're doing. So what is this information cleanliness thing, and why is it important? Well, one, you might get a lot of duplicate records, and that has to be eliminated. And you also might get inaccurate information that must be corrected. All right? That old phrase, garbage in, garbage out, right? So if you got garbage going into your database, that means any decision you make out of it is going to be garbage coming out. If your business intelligence is bad, you'll make poor choices. So you got to have good information to begin with. And it does take a process to make sure this is right. So possible problems with source data include dirty data. That's just things that are maybe misspelled. When instead of having someone's birth date might say born so one of your employees might have a birth date of 1876 instead of 1976, right? So that's dirty data. Missing values, maybe the birth date is missing. Inconsistent data, so in one place it might say 1976, and in another place it might say 1977. Which one's right? Or the data is not integrated. You might have the wrong granularity. So it might be too fine, like he was born at 3 a.m. on June 18th, 1976. Well, that's too fine, right? You don't quite need that. Or you might just say 1976 and not say the actual date. Or you just might have too much data. So there's a lot of potential problems here. And yeah, I know I'm talking about too much data, when in fact the fact of the matter is we are collecting so much incredible amount of data. Well, how do you know which data is the right ones to capture and store? So you can end up with too many attributes, too many data points that do not add value. You can think of it like this, as maybe we could have a security camera running, or 100 different security cameras running throughout their business, all pointing internally to what the employees are doing, right? Not pointing at areas where security could be a problem, but just the mundane of a guy sitting at his computer typing away. Certainly that's data you could capture, but it's too much, right? And it doesn't add any value, so why do it? So it's important to not have these types of problems. All right. So this term data marts came from the data warehouse concept. So if you think of data warehouses, are basically these organizational-wide databases that capture past behavior. But there's so much in there that, for one, you may not want everyone to have access to all that data. And even if you were willing to let everyone have access to the data, it may be too much for them to use effectively. And so data marts are essentially a subset of a data warehouse, in which only a focused portion. And I don't really care for this picture too much. This is the one that came with the book, the slides. Because really what you would expect to see here, the difference between like merchandising, advertising, and distribution, might be different colors showing up, or different, basically cutting and slicing out different parts of this huge data warehouse so that only each of these departments gets the information that they need to make decisions. All right, so that's a data mart. It's still very, very useful tools. If you get to see these, that's incredibly awesome. Now, what can we do with this? So 3 types of BI analysis, right? Now, we talked about collecting data. This gets into the analysis of data. Now, I want to give a little plug for a new certificate that we're actually trying to develop here in the College of Business, which is one for business analytics. And if you're wondering what business analytics is, we're going to touch a little bit on that today. It's a 4-class sequence. So why are we developing this? Well, because of all the businesses out there who realize they're collecting all this information and they can't do anything with it. The problem is there's not enough people that are trained to do business analytics. There's a huge opportunity here, and there's just not people. So if you guys are looking, you're finishing up your degree here, you're looking for a little something to give you a little extra bump over the competition, consider business analytics. And this can apply to things like supply chain and finance and marketing. And yes, you do have to know a little bit about the technology, but you also have to know a lot about statistics. You have to know a lot about business processes and even reporting. And we'll talk about some of that here now. And as you're reading through that chapter, you'll see that there is some of that that's being done. That they're doing some statistical analysis. So this is business analytics is a freaking huge growth area right now in our industry. In all businesses, actually, I shouldn't say just in our industry. It's across the board that a lot of businesses are looking at what we can do with this. Huge opportunities here. All right, so what are the three types of BI analysis? Well, number one is reporting. And it's not, creating information about past performance. Probably not the most glamorous thing out there, but still in a fundamental importance. But it's about the process. It's about processing structured data by sorting, grouping, summing, filtering, and formatting. So not glamorous, but absolutely essential for businesses to work correctly. And reporting is probably the easiest, the lowest level one that everybody's doing already. It's kind of the first step in business intelligence. The next level is data mining. And we'll talk a little bit more about the different types of data mining. There's really two major types. But it allows you to classify and predict based upon large volumes of data. So this is where statistics starts coming in, right? You have to be able to use sophisticated statistical techniques to find patterns and relationships. So a good reason to take a statistics class is so to help you do stuff like this. And if you don't think that businesses, and this is, again, across the board in all different types of disciplines, including finance and supply chain management and marketing, and I wouldn't be surprised to even see this developing more in human resources and in accounting and other areas as well. But to be able to use statistics effectively can really be a powerful technique. And then lastly, probably the most advanced one is something called big data. And it's really kind of scaling up the data mining to where you can find patterns and relationships in these large volumes of data. So not just simple relationships, but very complex relationships. And when we talk about big data, there's often the 3 V's that are discussed, which means there's high volume, high velocity, and high variety forces that you have to use different techniques to make sense out of. Now the book talks a lot about MapReduce. I don't really know if I think that's kind of the industry standard right now. Honestly, this is an area where I really need to do a lot more research on to discover what's going on in here, because it is rapidly changing. But some applications use reporting and data mining as well. All right, so the reporting one I think is not really worthy of much more comment on. Let's talk about data mining. And like I said, there's 2 types of data mining. The first is kind of the unsupervised data mining, where the analyst does not create a priori hypotheses or a model. So this might be something called like a cluster analysis. Oops, that's misspelled. It's not cluster. Cluster with an L, C-L-U-S-T-E-R. Is a common type of technique here. So there's a famous example of this where a grocery store was looking at patterns in shopping behavior, and they discovered a relationship that on Thursdays there was a high correlation between people having beer and diapers in their shopping cart. Now, the obvious question that comes up is, why is this? Doesn't seem real obvious. What's the connection between beer and diapers that people have them in a shopping cart at the same time? And no, it's not because people want to get so drunk that they just want to wear diapers. No, these are kids' diapers, right? Or baby diapers, right? Well, what they basically figured out was, Thursday. Well, what's Thursday? It's right before the weekend. So what were people doing on Thursday buying beer and diapers? Basically, they're stocking up. People want to stock up for the weekend. And so the reason why there's a high correlation between beer and diapers is because those are typical things people stock up on before the weekend. Now, it wasn't an obvious correlation. It wasn't obvious, but once they started doing a cluster analysis, they discovered this relationship. And then they could develop hypotheses and say, is this because people are stocking up for the weekend? And then you can actually test it and say, all right, I think this might be it. Let's test it and find out. But what this also does is give businesses, so let's take this grocery store as an example. What can they do about that? Well, now they can maybe define how they give out coupons in a different manner, such that maybe they give coupons for diapers that are only available on Thursday. Well, what does that do? Well, it gets people into the store to save some money on diapers. They're normally already there to buy and stock up for the weekend. But while they're there, well, guess what they'll probably buy? Some beer, which is a very high profit margin item, which can be very good for the business, but it's also good for the customers because they get the diapers cheaper on the day that they want to buy them. So that's unsupervised data mining. There's also a supervised data mining, which is basically you start with a model or an idea of what you want to check for. And so you have a model, you might even have hypotheses if you want to get all fancy scientific-like, but they're used for prediction, such as using techniques such as regression analysis. So this might be something, example of what is the cell phone weekend minutes. And that's something you can calculate. So you can do 12 plus 17.5 times customer age plus 23. So if you know the customer age and you know the number of months of the account, you can make a prediction for how many cell phone minutes they'll use on a weekend. Now, these numbers are pretty much made up and probably don't actually correlate with what an actual answer might be, but you get the point though. So it's essentially a formula. You can make predictions based upon a couple inputs. And then and if you create this, once you create this, you can test it and see does it actually work. And you can basically test things out, right? And see does it actually exist this way or not with the actual data. All right. So that's data mining. Again, very statistically oriented, but it doesn't usually deal with high volume situations. Generally deals with, it can be from a data warehouse, but it tends to be a little bit slower moving stuff, things that you can take your time to analyze. Now, what happens as it is today when you end up with just creation of massive amounts of data very quickly? So you have a huge volume, it's being generated very, very quickly, and it's in a lot of different formats, whether it's free form or from pictures or from different formats of web server and database log files and streams of data about users' responses to page content, graphics, audios, and video files. Whew. Big data is all about that. Now, I put a link down here if you guys want to check it out, a short history of big data. And actually, big data, the idea of big data has been around for over 50 years. So it's not like this is something that's, just came into existence. However, now the need for doing something about it is becoming exceedingly large. And so that is why it's gaining so much attention. You'll hear this term, big data, more and more, especially as you go out into the workforce. Because this, like I said, it's doubling every 12 to 18 months, the amount of data. And this is happening to all kinds of businesses. So the question is, with this huge volume of all this big data that's out there, what are we doing with it? How can we use this to solve our problems, to live a better life? All right. So I think I'll leave it there at that. What I do want to go on to now is the last one, a little bit, talk just very briefly about the alternatives to publishing business intelligence. And like I said, this is probably the least exciting as far as innovations that you may hear of. Because you can do email or various different collaboration tools as a way of sharing publishing information. It's pretty easy to do. The reports tend to be static. Once you create it and send it by email, you can't really change an email after it's already been sent. You can use a web server, which can create static or dynamic content. You can use something like SharePoint. This is a Microsoft-specific tool, again, for creating reports. Again, it just is variable. But at the high end, there's actually business intelligence servers that are becoming more and more, what's the phraseology here I want to use? Becoming more and more common in order to create very dynamic reports that are probably more difficult to create, but have far more value for people in industry. So the question isn't so much, is this a value? It is. People know that this is a huge value. And hopefully you see that this is a huge value. But the big thing is, can somebody do it? And that's where a lot of people are missing it. So, you might go back and question, why did we have this access assignment? It was really hard. I struggled with it. I didn't like it. Well, the fact of the matter is, knowing how to do any type of analysis on data is extremely, extremely valuable. All right? You can use that as a stepping stone to learning about business intelligence and learning how to work with data at a massive scale, to big data, and to be able to really do this incredible work with decision making and problem solving and just informing people about new things that no one ever thought of before. Especially if you've taken a statistics class or more than one statistics class, to really, just really dig into data and find things that you never knew existed, like a relationship between beer and diapers, right? But other industries are using this too. Like I've heard of, it was the, my brain's not working real fast right now. Casino industry, yes, casino. I believe it was Harrah's Casino. They use a lot of data about their customers to optimize who they target, and what type of offers they give to people. So they know, well, and you might be thinking, well, that's not very moral, and some people might have a problem with what they're doing. I'm not one of those, but even if you do, realize that those same concepts can be applied to every industry, right? So yes, the casino industry was able to, and in particularly Harrah's in particular, started analyzing their customer habits and being able to identify how best to get them to come back and spend more money at their casino, right? So yeah, you might say, some of you might think that's not a big deal. Some of you might think that's horrible of them. Whatever, I don't care. The point is that this can be done in multiple different industries, and you need to learn how to work with data, how to learn how to make sense out of all this data, right? To make better decisions. And that's really what it comes down to. It's about making good decisions, solving problems that your business might have, learning and educating and becoming smarter, to manage better projects, to help people create value, create valuable products, to create valuable services that ultimately the end consumer can live a much better life. All right. So to review Chapter 9. How do organizations use business intelligence systems? Well, there's a lot of different ways they do it, right? But it can be very simple. In very simple ways, they can develop this intelligence to very complex ways. But we did talk about the 4 tasks that they can use, including project management, decision-making, problem-solving, and informing. And the 3 primary activities, which is you have to acquire the data, then you have to analyze the data, and then you have to report the data. So in order to acquire data, we talked about how, using data warehouses and data marts. We talked about different techniques for processing business intelligence, which gets into that, analysis stage. And lastly, we looked at alternatives for publishing business intelligence. So that last activity. All right. So hopefully you've gotten a little bit of appreciation for business intelligence systems from this. Now we're going to switch gears and talk about geographic information systems. Now we're not going to go through that entire chapter extension. We're really just going to focus on the first one. What are the components of a geographic information system? And we'll tie it a little bit into what we have been talking about here with business intelligence. So as you might imagine, a geographic information system is essentially an information system that captures, stores, displays, and analyzes geospatial data. And what do I mean by that? I mean by locations, right? Where is something located? So basically it's laying data over an image of land so that we can better visualize that data. So it's a visualization technique. So we're still capturing lots of data. It's that we can pinpoint where it's at. So, I mean, you can look at all this data here, right? And so this table shows all kinds of data. How meaningful is that to you? Anyone can look at that and go, well, what the heck? There's a bunch of numbers that doesn't mean anything, right? But now what happens if we show this? Well, depending on what the context is here, we can see that, probably the red counties have a lot of something, and the white counties have very little of something. Or the cities, right? But we got a context now that we can start thinking about this and start making decisions, or maybe we want to focus on the red counties to help them become white, or maybe we want to help the white counties become red. So depending on what information is being applied here, we get an instantaneous picture of what's going on. Now, this is extremely valuable in a lot of different situations, and it could be something as broad as politicians and trying to analyze where should they, where should they go to, try to get votes, to how do they make decisions that impact the entire area. So when they're trying to decide, well, what types of what areas need the most support, which areas do we need protection, or better, we can look at crime maps and see like these areas need more police officers, or we can look at fire maps to see what areas get the most fires and what we can do to help that area. It can help city planners as they're trying to design or figure out where should we extend our the waterworks so that everyone has enough water. We can see at a quick glance the growth patterns over time. Mining companies have been using these for quite a while to map out where the raw materials are that they want to dig out of the ground. Utilities companies use these. Banking and insurance, logistics. All right. So the first example I talked about at the beginning here was about UPS and their Orion system. Well, that includes a geospatial component. So it includes a map of where the trucks are. They know instantaneously where they are, so they can even change their directions during the day. So if they're on track to go to the certain location, they can look at the map and say, all right, I see that there's 3 trucks all within 5 miles of this one location that now needs a pickup. Which one should we choose to go do that? And they can quickly make decisions like that. So it can impact the logistics in that way. Now, if you live in Greenville, one thing that our AITP club has done in the past is go to the 911 call center, and we actually had a presentation about Greenville's geographic information system. So the city of Greenville itself has their own map of the city of Greenville and of Pitt County. And so they have all this data already mapped out. But for like 911 call center, they actually have, whenever someone calls, it immediately identifies where they're at in Pitt County. And so they can then direct the police or the fire or whomever or the ambulance to the right location, they immediately know what directions to give and to whom based upon that, right? So it is a very, very powerful technique. Now, one thing that I've even seen, though, is even at it maybe at more of a personal user application. So many of you probably have used Google Maps before to map out where you're going, or some variation of that program. But I've seen it where you can actually take data from other sources and mash it together with Google Maps. And I saw someone who took a database of restaurant locations, fast food restaurant locations, and mapped it onto Google Maps. Now you're probably thinking, that's kind of whatever. But it's great if you're traveling cross country and you don't have any clue where the next restaurant's going to be. You can quickly pull up this application and look and see, at the next exit, there is a McDonald's. I don't really like McDonald's. So 2 exits from now, there's going to be a Wendy's. I don't love Wendy's, but it's better than McDonald's. I'm going to go to the second exit, right? So even at a personal level, you can create these type of applications that can be very, very effective. So how are these things created? Well, basically, geographic information systems actually come from satellite photos. So actually these maps, not satellite, I'm sorry, they can also be planes that fly over the land and just take pictures, very detailed pictures. And then they mesh them together to create these, right? But you can also combine this with external data. And that's what the 911 call center did, right? So they had all these pictures of the land, but they then meshed that together with all the addresses. So there's an address database of every single address in Pitt County. They mashed that together, right? So now you have a geographic information system application that can do a lot more, such as give police and fire departments addresses to go to if there's an emergency. All right. So to answer the questions, and this is basically what happens with all of this, a geographic information system. The hardware, a lot of this is not, we don't care so much about. The software is the geographic information system application itself. The data, we've talked about that. But here's kind of the key is in order to solve the problems and answer the questions and make decisions, it comes down to the procedures. So, and this is really true of a lot of business intelligence and big data in general, is what it's doing is it's driving to the procedures more than anything else. It's going to impact the procedures of business and of usage, of individual usage of things. So for example, for a GIS, different procedures like find a map, it has to have search features on that map, be able to zoom in and out, and navigate the map, change the views, add and edit user data, import and export bulk data, and manage map libraries. These procedures, though, now become far more important to business intelligence type systems, and including geographic information systems. Well, hopefully that sums up everything you need to know about these two topics. Or at least I shouldn't say everything you need to know, but it gives you a good grounding on the importance of this stuff as you move on forward. And do consider that a lot of businesses have these types of things already embedded within them. And if not, there's certainly lots of opportunities to start doing that. And even if you have a small business, you might be thinking, well, we're not going to have large amounts of data in a small business. That may be true. However, what you should realize is that you should have access to large amounts of data. And so even though you may not currently have that data, if you can get access to that data, maybe you have to pay somebody to get it, you can start looking for relationships in the data that may not already exist. And by doing that, you can find a niche that nobody else has figured out yet. Something that nobody else has solved, a problem. Or, maybe you find a solution that no one else has even considered, or a relationship that no one else has thought of. So lots of potential here. Don't just stop and think, well, it's not going to apply to me. Well, chances are it probably will. Take care.